So our last quadric surface is the hyperboloid of two sheets, and so the setup is just like the previous two. We've got all squared terms present, but one has a different sign. It's the odd man out, which again we can always take to be negative by multiplying through by -1. And again, we're going to be looking at level sets of the same function, but now we're going to be looking at level sets for where f takes a negative value. So like -1. And so the key point here is that we're looking where the sign of the value that we're fixing f equal to matches with the sign of the odd man out. Okay, that actually turns out to make a big difference. So let's see. So if we once again do a equals b equals c equals 1, then we're going to be looking at x squared plus y squared minus z squared equals -1 in this case. Okay, so what do we get? Let's start cooking up some traces. So for z equals 0, we have the equation x squared plus y squared equals -1. So it's empty. There's no solutions to that equation, right? Okay, so now if we do z equals 1 or z equals -1, again, since z appears with a square, it's going to give us the same thing in either situation. So then we've got x squared plus y squared, and then we add 1 to both sides and we get 0. Okay, so we get a single point. There's only x equals 0, y equals 0 satisfies that particular equation. So each of these ones just has a point. And then when we go higher and do z equals 2 and z equals -2, or some other number further down there, let's see, the equation is we've got x squared plus y squared, and then we're going to have -4, which we add to the other side, so we have 4 minus 1 is 3. So we're going to get a circle with radius square root of 3. And I have no idea and really don't care what the square root of 3 looks like, but it's enough to tell me that we've got some sort of circle. And so it turns out that what we get is something that looks like this. And so that is a hyperboloid again, but now it's a hyperboloid of two sheets. So there's the part that goes up and the part that goes down. And again, if we slice this with some other trace, like say fixing a value of x or something like that, then here maybe we fix like y equals 1 and chop it like this, and then you would see that there's a hyperbole as a trace for each of those. So that makes it similar to the other one, the hyperboloid of one sheet, but this one has no solutions for z equals 0. So if you were like swinging a sword through there, you just wouldn't be cutting off anything.